Hello, everyone. Thank you so much for being here. Super excited to be back in Amsterdam. I love this city. My name is Ali. I'm product manager on Firebase Performance Monitoring. And in a few minutes, I'm going to be joined by Jason, who's product manager on Crashlytics. And together, we work on app quality in Firebase. It is a subject that we deeply care about. We work on it very hard. And we think is highly correlated with user satisfaction and overall a more successful business. And we believe that because we've seen the data. We've seen that 50% of one-star reviews in the Play Store have something to do with stability and bugs. And on the other hand, 60% of five-star reviews make a mention of speed, design, or usability. So your end users really feel it when your experience is performant and is stable. And because of that, we've been working hard building a number of tools that help you with your app quality. And these tools span across different stages of your development lifecycle. Starting with the test and development stage, we build Test Lab for Android, which helps you keep a pulse on things like stability and performance before you get out into the wild. And then once you ship your app into the wild and you have real users using your app, we have tools such as performance monitoring and Crashlytics that allow you to understand the end user experience in production. Now, hopefully you got the chance to check out the talk given earlier today by Justin and Doug about building quality games. This talks a bit about Test Lab and other app quality tools. If you haven't, check it out on YouTube. But in this talk here, we're going to be focusing on three things. We'll talk a bit about performance monitoring. We'll talk a bit about Crashlytics and share some exciting news there. And we'll also share with you 7 tips to maximize your app quality. So let's start with performance. This year at I/O, we were super excited to announce Firebase Performance in beta for both Android and iOS. It is an SDK that allows you to understand how your app performs from the point of view of your users. It does things such as automatically collect data about your network activity and app start durations, but it also allows you to custom instrument things specific to your app. And then for all this data that is collected, we built a beautiful console that allows you to visualize the data. So that was a few months ago, and ever since then, we've been absolutely amazed at the reception that Firebase Performance has had. Today, just a few months after, we're processing as many as 30 billion daily performance events that are collected from over 200 million app installs. And we have apps from all over the world, from India to the Americas to Europe. We couldn't be more excited about it. And we thank you so much for the great feedback and enthusiasm that we've had. So let's talk a bit about what you want to have in a performance monitoring tool. We think that there's 2 categories of issues that every app developer should be concerned with. The first category of performance issues has to do with on-device performance. This is things like how smoothly your app renders, how efficiently you load your resources, such as files, specifically images, and so on. And for that, we built this feature called traces. And traces are basically records of performance. They are performance reports between 2 points in your app. And it could be any 2 points. It could be the time between a user taps on an item until they see the details page. It could be as short as a database fetch, or as long as an entire checkout flow. It's really up to you. All you need to do is create a performance trace object, give it a name like checkout flow to represent that action, start it and stop it. And when you do that, you get automatically the trace duration reported in the console. So you can effectively use these traces as timers. But it's not just timers, it's much more than that, because you get to also attach custom metrics to it using our counter API. So you can count things like how many times you dropped a frame during a trace, or how many times you made a call to the local disk, and so on. So you really understand the full picture on performance on the device between 2 points. So that's the first category. The second category is about network activity between your app and the backends that it uses. And for that, we automatically monitor for you HTTP and HTTPS requests from the time they're sent from your app until they're received. And we'll keep an eye on metrics like response time, upload and download payload size, as well as success rate. So we'll tell you things like how often requests come back with a 400 or 500. OK, so let's see what all that looks like in the console. So what I'm going to show you here is the out-of-the-box experience. This is things that you see in the console just by installing the SDK without writing any code. So I'm in my brand new Firebase console. I have the stability section expanded here, and I have performance selected. And the first thing I see is the dashboard tab, which gives me high-level data from both network requests and traces. So the first card here shows me a list of automatically instrumented traces. That includes things like a trace for a background session and the foreground session, as well as app start. And as you know, app start duration is one of the most important metrics that an app developer must optimize for. Next here, you see the network success rate over the last 30 days. So you can keep an eye on failures, when they happen, and how bad they are. The third card here is about network response latency. So it's a world heat map of latencies based on countries. So here I have my app offered in the US and Canada, and that's fine. India, on the other hand, has a higher network latency. This is something we can investigate a bit later on. Next, you get a breakdown of network volume by MIME type, so you understand where your data usage is going. And finally, you get a breakdown of app start durations by app version. Now here, you see something interesting. You can see that version 1.0, the latest app version I've released, has a much higher app start duration than the rest. As a matter of fact, if you scroll over here, you can see that the 95th percentile, so almost the worst case scenario for it, goes as up as 7 seconds, which is far from ideal. Now, this gives me a strong indication that something went wrong in this app version. But often when you investigate something like this, you want to understand if this issue can be attributed to any other factors. And that's what I can do by clicking on the details page here. Now I'm looking at app start duration broken down by multiple attributes, including app version like we saw earlier, but also by devices. Here, for example, I can see that the iPhone 6 has a higher app start duration than the rest of the devices, but that's kind of expected. It's a slower device because it's older. And I can see other breakdowns like which countries the users were in, which OS levels they were on, and so on. And I can see here that nothing else stands out. So now with a higher degree of confidence, I know that the issue that I have with app start duration is directly correlated with the latest app version that I have, and I can go to fix it. So this is a lot of powerful information that you get just by installing the SDK. All right, so that was a little bit about performance monitoring. What I'm going to do now is hand it over to Jason, and he's going to tell us all about Crashlytics. Jason.
Thanks, Ali. All right, since you heard earlier today, we've been working hard to bring the best of both Fabric and Firebase together. And that's why today we're extremely excited to announce that Firebase Crashlytics is now available to all Firebase developers. So if you're an existing Firebase developer, we recommend you test out Crashlytics and upgrade. And if you're an existing Fabric user, you're all set for now, and we'll let you know soon how you can take advantage of Crashlytics from within Firebase. But let's talk a little bit about what that means for Crashlytics to be available in Firebase. Because as many of you know, Crashlytics is the market leader for crash reporting, used by hundreds of thousands of developers in hundreds of thousands of applications and installed on over 2.5 billion devices. But what we're able to do now is bring Crashlytics into one unified console so it can truly work better together with all the other Firebase products that you know and love. And you've heard some examples of that today. And while doing that, we made sure to keep the install process amazingly simple. So whether you're using Gradle on Android, CocoaPods on iOS, you want to install the SDK manually, you can use your existing Google Services file and get up and running in a matter of minutes, just like any other Firebase SDK. And something that we're particularly proud of is while we were building Firebase Crashlytics, we did a bunch of usability testing and alpha testing with developers like yourself and got feedback on how we could really refine the user experience so you could get in and solve stability issues even faster. So that's something we're particularly proud of. But before we dive too deep into the features of Crashlytics, let's remind ourselves why a crash reporting solution like Crashlytics exists. So this is an example of a crash that Ali sent me. He was in Boston visiting me a couple weeks ago. We were practicing our talk. He was searching for burgers in Boston, and apparently he only gets expensive burgers. And right when you're at the key moment of this, filtering to try to get the results, app crashes. Obviously not ideal. So as a developer, I want to get to the bottom of this. And before using a crash reporting solution like Crashlytics, you might be staring at something like this. So if you actually know how to plug your phone into your Mac and find where they hide this crash report in Xcode, you're going to be looking at an unsymbolicated stack trace. If you look really close, you can see that at least my app code is in there, but you still can't do anything with this. It's still just nonsensical memory addresses. What you really want is a crash reporting tool that can take that crash, along with all the other crashes that are happening in the wild, group them, prioritize them, and give you an idea how your app is doing stability-wise, release over release. And one great measure of that is looking at your crash for user statistic. So we have a lot of customers who use this as a key performance indicator to know if their apps are getting more stable or less stable release over release. And all these crashes we get, that we prioritize them into what we call issues. And issues are ranked by the number of times they're occurring and the number of devices they're occurring on. And you can clearly see here the line of code that crashed, the file name, and we'll even do things like call out interesting bits of information, like maybe this crash is only occurring on iOS 11, so maybe that's indicative of something changing in the latest release, maybe a deprecated API that you're not supposed to be using anymore. We'll let you know that maybe this crash is only occurring on rooted or jailbroken devices. That could indicate that someone's using your app in a way that you didn't intend, so maybe you don't want to fix this crash. Just a couple quick things there to really help you know that, just to get a better idea of what you're going to be into solving this crash. Now, diving even deeper, you'll see that you get this issue detail page. So now you can see the full, now symbolicated or unobfuscated unobfuscated stack trace. You'll see how the crash has been trending version by version. Are you increasing in, is this issue getting worse? Is this issue getting better? You can see an operating system, device breakdown. And the console isn't the only place you can find out about crashes. We'll alert you real time via email the second a new issue arises. So you can have peace of mind whether you're out grabbing a beer or a cup of coffee that we got your back. We'll let you know when a new issue arises. Not only new issues, but also regressed issues. So if you close an issue, you think you're all good, and then we see that pop up on a new version, we'll let you know immediately about that. And there's one alert we think you should pay extra close attention to, and this is what we call velocity alerts. And velocity alerts are when one issue is causing a statistically significant portion of all sessions to crash. So this may indicate that you need to issue a hotfix right away or roll back because something really wrong is happening with your application. And you get all this out of the box. This with crash reporting and also some of the stuff that Ali walked through with performance monitoring. What we really wanted to talk through today is ways by which you invest a little more time in your upfront setup and ways that you can use Crashlytics and performance monitoring along with other Firebase tools. You can really maximize your app quality. So we have 7 tips for that. Start with Crashlytics, but before you do that, let's remind ourselves the crash that Ali experienced. He was searching for burgers in Boston, the expensive ones, and then he crashes. Now, if I'm lucky, I may be able to look at the stack trace, see the line of code that crashed, and know exactly how to fix that. But if I don't, I'm going to want to reproduce that crash. And a great way to retrace a user's steps is with custom logs. So from the issue detail page, you can see the logs tab. And diving into that, this is the order of operations that Ali walked through in a session. Everything from when the splash screen reloaded, all the way up to when he tapped a filter view and the app crashed. So if I actually can't figure out how he got himself in that situation because I don't understand, I can go look through custom logs and try to recreate the steps that he took. And you actually saw an example of this earlier today in the talk earlier in the Goldmine application. Now, a great feature that Firebase crash reporting had, actually, this is a code example. So this is actually the example of how to log custom logs in Crashlytics. Simple one line. This is where I'm logging the filter button tapped on my button action. And then this is what I wanted to mention. So a great feature that Firebase crash reporting had was called breadcrumbs. And breadcrumbs are a lot like custom logs, except for you get them for free with analytics. So this is a great feature that Crashlytics is going to be implementing soon. So if you're an existing Firebase crash reporting user, it'll be coming soon to Crashlytics as well. Now, sometimes it's not just about the order of operations that causes the crash. It's actually the context that the user is in. You could imagine maybe it's the size of the file they have that they're trying to upload. Maybe it's how many items they have in their shopping cart, the level they are on a game. In our case, it's actually what they're trying to filter for, what they're trying to search for, and particularly the expensive price category. So if I scroll through a bunch of sessions, I can see the other keys and values are changing, but price remains constant. So for some reason, when users are trying to search for the $3 level of restaurants, that's what's causing the crash. So I know that I need to go debug my application and figure out what about that data my app isn't handling specifically for that. And as I mentioned, keys are just key value pairs. So here's an example from the Friendly Eats application where I'm recording the key and value for all the items in the picker view. So those are two ways that you can really debug tricky issues. But occasionally what you want to do is you want to kick off a workflow before the debugging even starts, or for a really particularly critical part of your application. And now with Crashlytics, starting today, being an event source for Firebase functions, you can do that. So let's walk through an example. So imagine you have a purchase flow or something really critical in your application that you really, really want to monitor specifically and kick off a workflow around. And in our case, in Friendly Eats, it's actually our new reviews. That's a new feature we just launched. We hope it's going to drive a bunch of engagement, so we have a team standing by to make sure that nothing's going wrong there. So when I see a new issue in the new reviews view controller, I wrote a function to automatically send that issue to a Slack room. You can send it to email or anything else that you can do with functions, where a team of developers are waiting by to solve that very specifically. And you could imagine a use case where maybe I'm A/B testing this new feature, so it's not at the top of my list, but I know it's really, really critical. So I want to make sure someone's standing by to pay attention to this, even if it's not my top 2, 3, or 4, 5 crash. And this is an example of what it looks like in Slack. So you can see the new crash was detected in the reviews page. So we're going to dive into that crash and go directly into Firebase Crashlytics and figure out what's going on. And here's how you actually use that. There's a function where I'm registering a new function called new review crash that's going to get executed when we see something in that view controller. And if so, we're going to forward it to Slack with the message new crash detected in the review page. So this is just another example of how these two platforms are getting better together from day one. So Crashlytics as an event source for Firebase functions. So debugging crashes is great, but what would be even cooler is if you could prevent crashes before they even happen. Now, it sounds like a lofty goal, but there is one tip I recommend you try, and that is listening for the fact that a user crashed in the previous launch of your application. And you could do something like say you're sorry. But even more practically, what you might want to do is clear out any cache data that you have for that user. Because there could be a user that's in a state that every time they launch your app, you're trying to access something that's corrupt that you have in cache, and it's causing them to be in a perpetually crashing situation. So this is a great tip if you think your app may be able to take use of this, to make sure that you set your user up for success from the start if you detect that they crashed in the previous session. So these are a few tips with Crashlytics and how you can really maximize the most out of crash reporting. What I'm going to do now is turn it back over to Ali, and he's going to walk through some ways that you can get the most out of performance monitoring.
Thanks, Jason. So moving on to the performance side of things, a great tip we have for you is that you should monitor all your network activity in one place. And to consider why this is important, keep in mind that we used to typically build apps that were more or less talk to their own backend, and that's pretty easy to monitor. But what we're seeing these days more and more is that app developers include a lot of third-party SDKs into their app. Now, each one of these third-party SDKs would come with their own backend. So understanding network performance from the perspective of your user requires that you understand how all of these backends behave. And that is something you can do with a performance monitoring tool. So let's see how this can be done using Firebase Performance. I'm going to go ahead and switch back to the console here. And if you remember the last time we took a look at the dashboard page, we saw that there is a high network latency in India. So here I see a median overall of 7 seconds, almost. I'm going to go ahead and switch to the Network Requests tab and take a look at what I see here. So the first thing I see is a list of URL patterns. And URL patterns are basically aggregations of common URLs. So we'll take URLs that appear frequently, that are sent or requested from your app that would have dynamic IDs, like, say, a user ID. Would strip these away, and we would collapse them into a common pattern. And this gives you a better way of looking at meaningful stats. So here you can see a call to a third-party analytics service. There's an image service to fetch images, product details, and so on. You also see a couple of warning badges. The first one here is for the image service. And if I hover over it, it tells me that this particular image service has a median of more than 2 seconds. As a matter of fact, I can see here it's 5 seconds. Now, we saw that India has a higher network latency than the rest of the countries. And one thing that I want to do is see if that problem is concentrated in the image service. So I can go ahead and click on Filter, select Country, select India, and now filter all this data specifically for Indian users. And now I see that the median response for the image service in India is almost 20 seconds. And every other service seems to be fine. So now I know that this problem that I have in India with network latency is concentrated in the image service. OK, so that's one problem. The other one, if I hover over the other warning badge, complains about the checkout service having a success rate lower than 90%. So I'm going to click on it to see further details. Here I see a few metrics associated with the checkout service, things like response time and payload sizes. But what I want to look at is success rate, which in this case is almost 88%, obviously less than ideal. If I click on View More, not only do I get a breakdown by different attributes of this metric, like we saw with app start duration, but I also get a breakdown of the error codes that come back. So I can see that the majority of my failures for this particular service is 500 errors, with some 503s, 502s, and other 400 errors. But clearly, the problem is concentrated in 500 errors, and that's something that I can address on my server. So that's one data point, but I can further refine it with another data point using these attributes. So I can take a look through them to see if anything stands out. And indeed, I see that the country breakdown here tells me that I have a success rate that is almost perfect for the US and Canada, but in India, I have a 0% success rate. So now I know that not only do I have a 500 error, but it's also something that is appearing in India specifically. And that's a lot of information for me to get started on fixing this networking issue. And that is something that you can do consistently across all your backend services, whether it's something that you host on your own or something that is used by a third-party SDK in your app. All right. Next tip. Firebase Performance is a great companion for Android vitals. So if you've published an app recently to the Play Store, you probably noticed the brand new Android vitals section. And this is a section that gives you a lot of great data on your crashes, your ANRs, and also on your performance data. And you might have seen something like this, where Play tells you that you have slow rendering and/or frozen frames in your app. In this case, slow rendering talks about when frames take more than 16 milliseconds. And frozen frames is when frames take more than 700 milliseconds. So you have an experience where the app appears frozen for almost a second. And no one wants that, obviously. Basically, what this says is that your app has slow rendering. This is important information for every developer to have. But typically, the follow-up questions that we get when developers hear information like this is, where in my app does this happen? What is the context? Which activity does it take place in? Or even more granular, which action? And that's exactly the kind of thing you can use Firebase Performance for. So in this scenario, let's imagine that you have 3 activities in your app that are animation-heavy, and you want to understand and analyze which one of these has the biggest rendering issues. In the activity class, you can instantiate a couple of objects. First of all, you instantiate a performance trace, and you would also instantiate a frame metrics aggregator object. This is a class that Android gives you to allow you to collect frame data. And then in the onStart method, you would activate both of these objects. So you start the trace, and you start collecting frames data. And in the onStop, you would do a couple of things. Within your performance trace, you would add 3 counters, one for the total number of frames, one for the number of slow frames, and another for the number of frozen frames. And then you would iterate through the frames data that you collected throughout the trace. And every time you see a frame that takes more than 16 milliseconds, you would increment the slow frames counter. Every time you see a frame that takes more than 700 milliseconds, you would increment the frozen frames counter. And you would stop the trace. Now, the next time you go back to the console and you click on the Traces tab, first of all, you would see a number of new traces other than the ones that are automatically instrumented. In this case, the 3 activities that we instrumented using the code that we just saw. If I click on, say, the browse activity, in addition to the duration cards, I see new cards here for the counters that I added that tell me the median and the general distribution of the total number of frames, as well as slow frames and frozen frames. So now I can compare the proportion of slow and frozen frames to the total number to understand the rendering performance of this activity. And I can do it across all the other activities as well to understand the culprit. Where is my rendering issue taking place? So this way, you understand and discover the issues, performance issues in Android Vitals on a high level, and then use Firebase Performance to dig into the issue and get to the bottom of the solution. Also, pretty soon, we're going to be adding the capability to break down any of these metrics in the console by app version. So you're going to see cards that look like this and allow you to easily identify if you have a regression in a certain app version on a specific metric out of these metrics. Finally, wherever it makes sense, you should always consider using remote config to tweak performance on the fly. If you haven't used remote config, it's the service that allows you to set config parameters in the Firebase console and push these out to your end users without having to push an app update. And it turns out this is quite useful for tweaking performance. A very good example of this is tweaking caching logic. If you've ever worked on caching before, you know that one of the decisions that you have to make upfront is the cache size. How big is the cache? How much information am I going to save locally on the device, right? And this is an important decision because you want to optimize it for a couple of things. First of all, you want to optimize it for all your end users out there, and this is a difficult thing to do because you have a lot of users with a lot of end devices or a lot of device models and so on. And finding the optimal value is not an easy thing. There's another problem with this as well is, let's say you start with some value and later on you figure out another value that is more optimal. Now you have to actually update your code, push an app update, wait for users to pick up the update. It's just not that practical. Instead, what you can do is have the cache size value read from a remote config parameter. And then in your caching logic, you would wrap that logic around with a trace. So you can start a trace, call it image fetch, and then after the caching logic, you would stop the trace. And within the logic itself, every time you find an image on the device, otherwise you have a hit, a cache hit, you would increment a counter for that. And anytime you don't find the image on the device, you have to fetch it from the back end, you increment a counter for cache misses. Now, before pushing your app into production, you would go back to the console, and this time I'm going to start with the remote config console. And I'm going to go ahead and add my first parameter here. I'm going to call it cache size. And I'm going to start with the value of 0, which basically means no caching, right? I'm going to add the parameter, publish the changes. And now I'll head back to performance after I've pushed my new app version. I'll click on traces. And I can see this newly instrumented trace called image fetch. I'm going to click on it. And as I expected, I have counters for cache hits and cache misses, and I have 0 cache hits because my cache size is 0, right? OK. So now I head back to remote config. I would edit this value, and now give it a value of 20 megabytes, hit update, publish the changes. And a few hours later, I would check on performance numbers. So I would refresh this page, and now, as I expected, I see cache hits that are non-zero. And to get an even better look at this, I would click on the Overtime tab, and I can see that my cache hits have picked up from 0 in the last few hours. And just like that, I can start monitoring or optimizing the value, and therefore optimizing the performance for the end user using remote config, and seeing how things are affected using performance monitoring. And this way, I can optimize for the end user experience without ever bothering the end user with picking up new app updates. And that was it. So these were 7 tips to maximize your app quality. We highly recommend that you take advantage of them. If you do that, you'll be in great shape. So please check out Crashlytics and Performance Monitoring. The best way, as always, is to start at firebase.google.com, where you can find documentation on getting started. Definitely check out the brand new Crashlytics in Firebase. It's a great experience. And come to us in the Ask Firebase lounge. Ask us questions. We'd love to have a chat. And thank you all so much. Enjoy the conference. Enjoy Amsterdam. And we'll talk to you in a bit.